Have you ever wondered how something can emerge from nothing? Whether stars and planets might be alive, or if experiments at the Large Hadron Collider could be dangerous? These thought-provoking questions and more were tackled in a recent question and answer session, shedding light on some of the most puzzling topics about our universe. The cosmos has always fascinated humanity, and delving into these mysteries not only expands our knowledge, but also challenges our perceptions about existence itself. From groundbreaking experiments to philosophical musings, let's unravel these enigmas together. The Big Bang and the origin of the universe. A common query is, how can something come from nothing? Often tied to misunderstandings about the Big Bang theory, this question resonates with people who struggle to grasp where the universe originated. Importantly, the Big Bang theory does not attempt to explain the origin of the universe. Instead, it describes how the universe has become less dense over time, indicating that it was denser in the past. By tracing back its expansion, scientists have reconstructed a timeline of the universe that begins approximately 13.8 billion years ago. To understand this better, think of a car moving westward. Observing it, you might deduce it was farther west earlier. Similarly, the Big Bang suggests the universe was denser and hotter as we rewind time. However, the theory doesn't address what preceded this state. Scientists acknowledge they don't know where the universe came from, leaving room for various interpretations, including religious beliefs. Some hypothesize the existence of multiverses, while others speculate about quantum fluctuations as the spark for creation. The consensus remains that we don't yet understand the ultimate origin of existence, and that's okay because scientific progress thrives on unanswered questions. Could stars and planets be alive and conscious? The idea that stars and planets could be alive or conscious might sound far-fetched, but it's worth exploring. For planets, the Gaia hypothesis provides a compelling perspective. This theory posits that Earth behaves like a giant organism, maintaining equilibrium through cycles such as temperature regulation and carbon sequestration. For instance, increased atmospheric carbon dioxide leads to enhanced plant growth, which sequesters carbon and stabilizes the climate. Such self-regulating mechanisms make Earth uniquely suited for sustaining life over billions of years. Life on Earth evolves through phases, from simple organisms to complex technological civilizations. This raises a fascinating question. Could a planet wake up and achieve consciousness as a natural evolution of its inhabitants' technological advancements? Some researchers even consider the possibility of planetary intelligence, where interconnected systems, biological, geological, and technological, might collectively form a higher consciousness. Stars offer an even more speculative scenario. While they are primarily composed of gas and plasma, some theories suggest that under extreme conditions, such as the presence of cosmic strings, rudimentary forms of life might emerge. Cosmic strings could theoretically interact with the fluid environment of a star, fostering chemical interactions. Though there's no evidence to support this yet, the possibility stirs the imagination, encouraging us to think beyond our Earth-centric definitions of life. Is the Large Hadron Collider dangerous? The Large Hadron Collider raises concerns about potential risks, such as creating black holes or particles that could harm the Earth. However, scientists conducted extensive studies before the collider was activated, considering these possibilities. Cosmic rays, high-energy particles from space, regularly strike Earth's atmosphere, with energies far surpassing those produced by the Large Hadron Collider. If these natural events haven't caused catastrophic consequences, it's unlikely that the Large Hadron Collider poses a significant threat. What if the Large Hadron Collider did create a black hole? Theoretical calculations suggest such a black hole would be minuscule and evaporate almost instantly due to Hawking radiation. Even in the unlikely event it persisted, its interactions would be so infrequent that it would take an astronomical amount of time to pose any danger. Furthermore, these experiments are heavily monitored and reviewed by international teams of experts, ensuring safety protocols are robust. For now, The Large Hadron Collider and similar experiments remain vital for advancing our understanding of particle physics, unlocking mysteries about the fundamental building blocks of the universe. Detecting neutrinos. The ghost particles. Neutrinos are elusive particles that rarely interact with matter, yet scientists have developed ingenious methods to detect them. One of the most significant facilities for this purpose is the IceCube Neutrino Observatory in Antarctica, a cubic kilometer of ice embedded with detectors. When a neutrino interacts with ice, it creates a cascade of particles that the detectors capture. These cascades produce faint flashes of light called Cherenkov radiation, which are then analyzed to trace the neutrino's origin. By analyzing these cascades, scientists can trace the neutrino's origin, such as a supernova or the sun. This capability is advancing multi-messenger astronomy, combining observations of light, gravitational waves, and neutrinos to provide deeper insights into cosmic events. For instance, the detection of neutrinos from supernova SN 1987A provided critical data about the processes occurring within an exploding star. Plans are underway to expand IceCube into a larger facility, enabling even more precise measurements and opening new windows into the high-energy universe. How many planets can a star have? The maximum number of planets a star can host depends on gravitational stability. Planets must orbit without disrupting each other. Our solar system, with its neatly spaced planets, demonstrates this balance. Beyond our system, astronomers speculate about systems with dozens or even hundreds of planets, especially around massive stars or black holes. For instance, the TRAPPIST-1 system, located about 40 light-years away, boasts 7 Earth-sized planets, 3 of which are in the habitable zone. One imaginative scenario involves a supermassive black hole anchoring a system with multiple stars, each surrounded by planets in stable orbits. Such a setup could theoretically support thousands of habitable worlds, revolutionizing our understanding of planetary systems. Hypothetical models, like the one proposed by astrophysicist Sean Raymond, envision systems with hundreds of Earth-like planets orbiting in stable configurations. These futuristic ideas stretch our imagination and challenge conventional definitions of what constitutes a solar system. Milestones in human space exploration. For adults alive today, the most significant upcoming milestones in space exploration include the return to the Moon under NASA's Artemis program, potentially by 2026, and the first human mission to Mars, possibly in the 2030s. Establishing permanent research bases on the Moon and Mars could be transformative achievements within our lifetimes. These milestones are pivotal for testing technologies that will enable deeper space exploration. However, grander milestones, such as interstellar travel or colonizing other planets, are likely centuries away, awaiting technological and societal advancements. The younger generation may witness breakthroughs in asteroid mining, or even the construction of large-scale space habitats like O'Neill cylinders. Such advancements would signify humanity's transition from an Earth-bound species to an interplanetary civilization, shaping the future of exploration and survival. The evolution of Universe Today. Universe Today, a platform dedicated to space journalism, has evolved significantly over its 25-year history. Initially focused on general news and press releases, the site now specializes in cutting-edge advancements that pave the way for future space exploration. For example, it frequently highlights revolutionary technologies like ion propulsion systems, reusable rockets, and next-generation telescopes, such as the James Webb Space Telescope. By highlighting innovative propulsion systems, telescopic discoveries, and more, Universe Today caters to those eager to understand what's just around the corner in space science. This targeted approach has enabled the platform to thrive in an era where traditional media outlets face challenges. Its focus on engaging, well-researched content ensures it remains a go-to source for space enthusiasts worldwide. That's all for today's video. If you enjoyed this video, make sure to like and hit subscribe button. Together, let's keep exploring the cosmos one question at a time.